Welcome to EDU World Space.
Alright, so here is the problem 108 in chapter 19, and this question are going to ask various questions about carbon disulfide. Part A is asking us to draw the Lewis structure of this molecule, CS2. So the Lewis structure of CS2 will look like this. Carbon as the center atom and sulfur around carbon. So carbon has 4 valence electrons and sulfur will have 6. So as a result, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So these 2 electrons bond together and this bonds together. So there are 2 pairs of double bond between C and S. So what do you predict the bond order of CS bond? In this case, the bond order of C and S will be 2. Part B, use the VSEPR method to predict the structure of CS2 molecule. So from the Lewis structure above, we can see that the center atom C is bonding with 2 sulfurs, and there are no lone pairs of electrons around the carbon. So according to the VSEPR mode, this is a linear structure. Now we look at part C. Liquid CS2 burns in oxygen with blue flame, forming CO2 gas and SO2 gas. Write the balance equation for this reaction. So we have CS2 liquid burns in water, burns in oxygen, so it reacts with oxygen and result in CO2 and SO2. So oxygen is a gas, CO2 is a gas, SO2 is a gas, CS2 is a liquid. So looking at the carbon, 2S, 2 SO2. So there are 2 oxygens, 2, 2, 4, 6 oxygens in total. So there's a 3 before the oxygen. So this will be the balanced equation for part C. Now let's look at the question D. Using the data in the table and in the appendix C, calculate delta H and delta G. So after the calculation, we also need to determine the reaction, is it endothermic or exothermic, and whether it's spontaneous or not. So to calculate delta H values of the reaction, that will be the delta H of formation of the products minus the delta H formation of the reactants. So it will be equal to the delta H0 of carbon dioxide gas plus 2 times the delta H0 of SO2 gas minus the delta H0 of CS2 liquid minus 3 times of delta H0 of oxygen gas. So this number is equal to negative 393.5 plus 2 times negative 296.9 minus 89.7 minus 3 times 0. So by doing the math, we will get a number delta H0 equal to negative 1077 kilojoules. So then we calculate for delta G0 of the reaction. That will be the delta G0 of the products minus the delta G0 of the reactants. So the products are CO2 gas, 2 times the delta G0 of SO2 gas minus delta J0 of CS2 liquid minus 3 times delta G0 of the oxygen gas. This is equal to negative 394.4 plus 2 times negative 300.4 minus 65.3 minus 3 times 0, and that is equal to negative 106.5 kilojoules. So this is the delta H0 right here. And this is the delta G right here. So we know that the delta H value is negative. So that means the reaction is exothermic process. And we also see that the delta G0 value is negative. That means the reaction is spontaneous. So that is the part D of the question. Now let's look at part E. Part E is asking you to use the data in the table and calculate delta S at 298 Kelvin for the vaporization of CS2 liquid. So the vaporization process is the CS2 liquid goes to CS2 gas. So how do we find the delta S value? We're going to need delta G value equal to delta H minus T delta S. This is vaporization process, vaporization and vaporization. So if we have this formula, we will get delta S0 of the vaporization process equal to delta H0 of vaporization minus delta G0 of vaporization divided by T. So if we solve this for delta S vap, we'll get delta S equal to delta H minus delta G divided by T. So now we calculate for each part delta G0 of the vaporization. This is equal to delta G0 of the CS2 gas minus delta G0 of the CS2 liquid. This will be equal to 67.2 minus 65.3, and this is equal to 1.9 kilojoules. For the delta H vaporization, you will need to use delta H0 of CH2 gas minus delta H0 of CS2 liquid. And this value is equal to 117.4 minus 89.7, and you will get a number of 27.7 kilojoules. So now you have the delta G, the delta H. We're going to plug these numbers into this equation right here. So delta S of the vaporization process is equal to 1.9 kilojoules. So it's the H minus the G. So we have 27.7 kilojoules minus 1.9 kilojoules divided by the temperature, which is 298 Kelvin. And that you will have 0.0866 kilojoules per Kelvin. Or you can simply say 86.6 joules per Kelvin. So we see that this is a positive number. So delta S vaporization is positive. So this is because the gas phase will occupy a greater volume compared to the liquid. So the molecules in the gas phase will have more motion freedom and a larger absolute entropy than the liquid. The last one, part F. Using the data in the table and your answer to part E, estimate the boiling point of CS2. So we're going to find the boiling point of CS2 liquid. And do you predict that the substance will be a liquid or a gas at 298 Kelvin? So what is the state at 298 Kelvin? So at boiling point, the delta G of the system will be equal to 0. And we know that delta G is equal to delta H minus T delta S. So if that is equal to 0, we will have delta H equal to T delta S. So this temperature of boiling point will be equal to the value of delta H divided by delta S. So we look up the numbers delta H and delta S right here, 27.7, 86.6. So delta H divided by delta S will be equal to 27.7 kilojoules, and delta S is 0.0866 kilojoules per Kelvin. And by doing the math, you will get a temperature 319.9 Kelvin. So this is the boiling point of CS2. So at 298 Kelvin, this is less than 319.9 Kelvin. So at this point, CS2 will be liquid.